I was like, what is that? Oh, it's my arm. Okay, so last time we talked about infinite limits, right? Limits at infinity. Kind of led to the idea of horizontal asymptotes. Yes. Right before class, I was answering a few questions about those. Let's do a little freakier problem.
2.6.
This is still 2.6, yeah. Oh, I forgot to finish my announcement. I got distracted. The test is still Wednesday. Everybody's got a practice test. It will not include section 2.8. We're going to push that. It actually works. I've done that in the past on purpose, so I might as well just do that again. Right, so 2.8 will be on the next test. And it's kind of nice because 2.8 directly leads into chapter 3, so it still works pretty well. So today we're going to finish 2.6. We're going to start covering 2.7. And then Friday will be review day. I'll have the answer key for the practice test. Everybody with me? Look at that. Look at that. No epsilon delta on the quiz. The test is going to cover one less section. Don't get used to me being so nice.
You're so nice.
I'm trying it out and it feels icky. Like I said earlier, in bonus form, if anything. So let me see. Did I put on the practice test? Yeah, my tests have, every test I give has 3 bonus questions.
3? And they all work the same as a normal.
So you could get 106 on every test. All right. Now, will the bonus questions be easy? No. Let's see, real quick. With that change, so here, number 7, I did put that down for an example, but this would be bonus, right? You guys with me? So I put an example down here. If you want to try it out, you can, but it will be a bonus question on the test. Let me see. Oh, number 8 is from section 2.8. So number 9 obviously is 2. You guys with me?
Yeah, I was kind of confused because I was like, we haven't even touched on
Well,
this
again,
yet, so.
I gave you the practice test way early.
Okay.
So originally we were going to cover eventually 2.7, 2.8. So yeah, there were going to be problems on here you had never seen yet.
Yeah.
I think that's the only 2 that are affected by that.
And the test is Wednesday, right?
Yeah. Test is still a week from today, yes. What's happening Monday? Holiday, exactly. So this Friday, what's happening this Friday? Review day. Yeah, so this Friday is nothing but review. All right, here we go. Let's finish up 2.6. So let me put this down here and see what your reaction is. No, it doesn't matter, Jeff. Say again, sorry?
Is it mandatory to come Friday?
It's as mandatory as it is to come any day.
Okay.
Yes. Friday is just another day that we meet. I like it. And I like that. You should petition for a bill that Friday should be optional, everything, but at the moment it's not that way. Too bad. So let me see. Let me make something. Yeah, why not, Jeff? There we go. Isn't that yummy? So that's a little more than what you did in pre-calculus, right? Pre-calculus, you focused on rational functions. Anybody tell me why that's not a rational? Why that is not a rational function?
Is it a square root?
Yes.
I know what this is. I recognize this.
I love that. All right. It's not rational because rational functions by definition are ratios of polynomial functions. So the square root does not match that definition. But we can do the exact same thing that we did when we divided by the highest power of x. Now be really careful. Can anyone tell me what the correct highest power of x is in this problem?
Just once. Yeah.
First power, yes. Because, is that bottom really squared? No, because there's a square root on it, so it really would come out to some kind of x. Do you guys see that?
Yes.
So I'm going to divide top and bottom by x. Now what's wrong with trying to divide a square root thing divided by a not square root thing? Are you able to do that? Are you guys with me? They have to be the same root, of course, to be able to divide them, yes?
Yeah.
So for example, if I had square root of x divided by x, can I cancel the x's?
Yeah.
Here's one of my favorite answers I ever got for real. I used to joke about this, and then I got that as an answer once, and I was like, what do I do? Okay. I'm sorry if you're out there going, what's wrong with that? No. So, okay. If you are, please, dear God, come see me.
Someone gave up. They were like,
Yeah. So what I'm going to do is I've written x down. Is there something else I can write here that would have a square root on it that's equivalent to x?
Square root x squared.
Yes. Now I'm able to do the division on the bottom. Yes? So now it's able to go inside the root because it's already in a root itself. You have to have the same root to multiply or divide things. Yes? So on the top, I get 2 minus 3 over x. Yes? Is that, sorry? Yes?
I thought you had to do the same on the top as the bottom.
You totally do. What is the square root of x squared, especially considering we're going to positive infinity, right? Square root of x squared is x.
Okay.
I love it. Yes?
For like the homework to get credit, do you have to do it that method, or can you just like plug in the infinity and then
If you show me how do you plug in infinity? You don't have to get infinity to be able to plug it in. If you are able to get infinity, I'm not sure if I want you to show me that because I think my mind will melt. Right? I think that's what's inside the suitcase in Pulp Fiction. Is infinity? No, nobody.
I've never seen that movie.
You got to. I'm sorry. No, you don't have to, but you should. Okay, enough of that. So no, you can't. In fact, one time I had people. Real quick side note, because that's a good question. I had people doing stuff like this. Get it? Become an infinity. Pretend like that's an infinity, not a lazy 8. What's wrong with that? I cannot plug infinity into something. I can't because is infinity a number? No. So what I got people to do instead was to put 1 over BFN and then go one more step. And what does BFN mean? It means big freaking number. Right? I could put a big freaking number in. So I thought, and that seemed to help them think about what it means the limit will be. If I put 1 over a really big number, the answer is really tiny, so that limit is 0. Now I'm hoping some of you guys don't have to do that. You know this limit is 0 because when the bottom gets really big, the whole thing goes to 0. Does it ever get to 0? Shit, no. Yes.
My old cow teacher would just have us plug in infinity and then we'd do the arrow and then we'd write 0.
Oh, God.
Yeah.
Okay.
Yeah. Because like he's just
And real
just,
quick,
like,
real
added
quick.
and then,
That's not like the biggest problem.
Yeah.
You understand?
yeah.
But it is a problem. You
Okay.
cannot plug infinity in because it's not a number.
Yeah.
So part of me just feels like, damn it.
Talk to Greenneck about it.
Oh, it's Dan. Okay.
Yeah.
His office is right across from mine, so I'll have a little discussion. Now, again, part of it is kind of opinion,
Yeah, of course, subjective.
but I'm right.
No, that's fine. Yeah.
No, sorry. I could be wrong. Who knows? But all right, let me come back to this. Everybody got the top here, right? This is just like we did before. On the bottom, now I can bring the x squared in, so I get 5 minus 7, not minus, 5 plus 7 over x squared. Is anyone not sure where that came from, either one of these? I'm just dividing each by x, dividing each thing inside by x squared. And of course, now, this is sort of related to what you're saying, but without writing infinity in, because you cannot do that, what does this go to? 0. What does this go to?
0.
Goes to 0 even faster. Yes?
I get that, but this is kind of like a little side question. Will we ever get a problem? So you see where on the denominator it has 5x squared?
Yes.
So let's say that were to be a 3, right?
Yes.
And you said we can't apply anything with like x and then square root x squared, and that's the same thing.
Here,
And
so
then
here's.
square root can cancel out.
All right, I love it. I'll do a problem just like that next. Okay. All right. So now we can. What is this limit then? Be careful. What's left? 2 over radical 5, which of course is 2 rad 5 over 5. Yes.
Oh yeah.
Get into the habit of rationalizing your answers. So it's the same thing we did before. We just have to do a little finagling because of the root. Yes.
Eventually, like, do we still have to rationalize them, or does it not matter
Yes.
Always.
So get used to rationalizing these, right? I like it. Okay. So that's an example of a freakier problem. Let's look at another one. What about this thing?
Oh, I kind of. So, if you take a VFN and plug that into X, then, like, eventually X squared plus 1 is just gonna be more like X squared, and then the square root of X is, X, so it's basically 0.
True. I like it. Okay, so let's figure out what the hell just happened. One thing you cannot do for sure, and now you all know exactly why. You definitely can't do this shit. Right? I don't know what infinity minus infinity is. I don't know what that is.
You're up.
Not really. So because infinity is not a number, infinity is a process. So the answer could be 0 if they're both going to infinity at the same rate. Stop for a minute. If the first dude's going to infinity faster than the other dude, then the answer would be infinity. Right? If he's going to infinity faster than he is, the answer would be infinity.
What makes you think they're going to infinity?
All right.
Oh.
So for example,
I got it.
that's not what's happening with this problem because of what you said. This is basically an x. The 1 means nothing when x gets really big. You guys sort of with me? Okay. So this is basically like x when x gets really big. X minus x is 0, so it is approaching 0. They do both go to infinity at the same rate, so they're always constantly canceling each other out for the most part. I like it. Look at this example, an easier one to think about. Become a 3. Okay. Become a 3. Considering what I just said,
Just that X cubed is
Yes.
going faster than X.
yes.
Okay.
So what do you think that difference becomes over time? I think I heard it back there. Infinity, right? Because this is going to infinity faster than that. I like it.
So what would be the answer to the first one?
This would be 0 because this by itself is approximately x when x gets really big. When x gets really big, how important is 1? Not. So this effectively is that when x is really big. If x was a trillion to the trillionth to the trillionth to the trillionth, is adding 1 to that doing anything? No. So effectively, the bigger x gets, the more that just becomes x. And what's x minus x? 0.
So like he said, you could write big freaking number minus big freaking 0.
Not really, no.
Okay.
You can't do that. Because again, isn't this a big freaking number minus a big freaking number?
Yeah.
So why is this answer infinity then? Because this one is going to infinity much faster.
Yeah. Still wants one first.
Watch this. The second one is pretty straightforward. If I factor this, what is this doing as x goes to infinity? As x goes to infinity, what is this doing? Oops, sorry. Just tell me you can't see it. As x goes to infinity, x is going to infinity. As x goes to infinity, what is this doing? No, infinity. So isn't infinity times infinity is going to infinity? So I rewrote the subtraction as a product. Yes?
Yes.
Okay. First one's a little bit freakier, but I just wanted to show you how there are more indeterminate forms than just 0 over 0. In fact, later we're going to see this is indeterminate.
Yes.
What's 0 to any power? 0. What's anything to the 0 power?
1.
1. So 0 to the 0 is somehow 0 and 1. So that is indeterminate. Right? So later this semester we're going to start to bring in more indeterminate forms. Okay. So I just want to make these couple of of examples to show you how to be careful in general. Okay. All right. I think that's all I got from 2.6. So that was just the freaky little things that kind of pile on top of 2.6. So let's talk about 2.7. How much time have I given myself? No time. So I'm so happy I put 2.8 off. This is where we finally come back to where we started. The very first thing I kind of talked about once we were done on chapter 1. The very first calculus idea I tried to get across was, how do I get the slope at a point? Remember that? Anybody? Remember that? And there were kind of two ways. You could either take 2 points around that point to kind of estimate, right? That was the secant line approach. Or you could have one kind of come closer. And that's, remember this when you're making all those tables, figuring out the slopes. That was in section 2.1, I think, right? But then we had to take a sidetrack and make sure we understood limits, because we knew that limits were a big part of getting there, right? So we had to just understand limits by themselves, and that's what all those section 2.2 through 2.6 was basically, right? That was all just making sure we understand what the shit limits are, because that's a huge part of figuring out the slope of any function at any point with a limit. And again, why? What is it? Why does it not make sense to say what's the slope at this point? Well, we always need how many points to get a slope? 2. So now we definitely should feel really comfortable coming back to this idea. Given any function, I have multiple colors here. Let me see if you guys can tell the difference. Let me just draw a function. Hi-ya! Okay. If I want to know the slope at a point, right? One thing I can do is I can take, so here's the slope at that point. Bam, 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 bam. That's the tangent line, right? The approach we take, there's 2 approaches. One of them is to take some other point Let me see if that makes sense. I should have made this a little more pronounced, but oh well. Take another point that's not too far away. What would the slope be between the 2 points I've put up there? What is that slope between those? It's obviously not the answer, right? Slope between those 2 points? It's not quite the answer. But what is the slope between those 2 points? Yes. Difference in the y's divided by difference in the x's, right? Just algebra. Where does the calculus come in? Well, what am I going to let happen? In order to find the slope at A, and the point I picked, that slope is obviously, is that slope too small or too big? Too small. It's got to be steeper, of course. That's the slope that I want at that point. What do I allow to happen to figure out the slope at that point?
Get it closer to A.
Get what closer to what?
Get X closer to A.
X closer to A. So, all right. So that means the actual slope at A is going to be the limit as X goes to A of this expression. What's up?
Remember that.
Okay, good. Why is it not an issue that this cannot be A, right? Why is that not an issue, of course? This can't be A, correct? Why is that not an issue? Come on, you guys can do it. Because the limit doesn't let X get to A. It gets really close, but doesn't touch it like that dude in the Blob. He touched it. Why did you touch it? And then the whole movie happens. You could have went like this one. That's weird. I'm getting out of here. So the limit, that's weird. I'm getting out of here. It doesn't get there. Okay. So for example, let's do a problem. In the little bit of time I have left for myself. Let's figure out the slope at x equal to 1 for f of x equals x squared. It's a very, very classic problem. And just a real quick sketch. The problem didn't say to graph it. But if I'm you, I'm going to graph a lot of problems, even the ones that doesn't say anything about graphing, right? So I want to know this slope right here. What's that slope right there? Now tell me something about that slope. Anything. It's positive. So it's not 0. It's not crazy big, but it's not like stupid small either. So, I can't. Say again?
It's about 1.
It is about 1, sort of, almost. But it's on the order of 1. Especially the way I've drawn my poor little parabola. Are you with me? That's just a rough sketch. So, okay. So how do I do this? So if I want to know at 1, so A equals 1. This whole process, A is the point that I'm interested in. X is some other input that I let get close to that.
Would it be the limit is x goes to 1 of x squared?
No, definitely not.
Oh, okay.
Careful. So if you need to, here's 1, and what's 1 squared? 1. Holy shit. Pick another point, X. Right, so here's that point. What's the output there? X squared. I love it. Right? I've got 2 points now, don't I? In fact, this tells you exactly what to put down there. The limit as x goes to a, which is 1. I want to get to 1 of f of x minus f of 1 divided by x minus 1. And now you see that the limit problems we were doing were not in a vacuum. They are actual things you will see. Do you know how do we do this? If I plug a 1 in, what do I get? Unsurprisingly. Say again? 0 over 0. That's a problem, right? Now, real quick. In the future, we will have indeterminate forms like this, and people will yell at me that, look, you're writing infinity. See how they're in parentheses? That captures the form of it. That's not like an answer. That's the form. So that's why I put this in parentheses. 0 over 0 is meaningless, but that's the form of it. Right? So I know it's indeterminate. What do I do to this then? Yeah. This is beautiful. X minus 1, x plus 1, divided by x minus 1. Die. Can I actually evaluate the result now? What do you get? 2. Doesn't that kind of match up with... So like you said, it's about 1. On the order of 1, I would say. And the answer actually is 2. What would the slope be at like 3? Would it be bigger or smaller? As I follow the parabola, at 3, the slope is going to be way bigger. Every time I move over, I'm getting bigger slope, right? Okay, maybe. All right, now look what we can do. Remember this problem? Can you guys find the equation of the tangent line? Yes, you can, because how do I find the equation of any line? What do I need to find the equation of any line? I need the slope and the y-intercept or any point.
Yeah.
Do I know the slope?
Yes.
Slope is 2. Crazy. Do I know a point? Yes. 1, 1. Yes? And then do you guys remember this? Y minus y1 equals m times x minus x1. Of course, you could also do y equals mx plus b and solve for b, whichever method you remember. If you don't remember either one, that's a problem. So you get y equals 2x minus 1. All right, I added the 1, blah, blah, blah. Okay. So, last thing I want to tell you, because it's all the time I got. 2 things. This is a more complicated version of an algebra problem. Remember what they said? Something like, find the equation of the line that goes through 3, 7, and it's parallel to y equals 7x minus 2. You remember that kind of problem? You had to find a slope. Okay, it's parallel, so the slope is the same. And you needed a point. They gave us a point. All right, so now do we have another way to figure out slope now? Yes, we know I have another way to figure out slope. I just need the slope that I get from calculus, and I need a point. Well, they got to give me a point for me to do anything. Yes? And then I do the same thing I did in algebra. I can do y minus y1 business, or I can do mx plus b business. So it's just an algebra problem, slightly elevated. So last thing I want to say is this. So this process gives me the slope, and let me finally give you the actual notation for this. This will be the f prime at A. So the way you read this little dude, Autobots roll out. No, prime. F prime of A. So the prime means the slope of f at A. The little prime symbol means the slope of the function at A. So for example, for f of x equal x squared, f prime of 1 is 2. So what does this statement mean? The slope of x squared at 1 is 2. Maybe? 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 Yes?
Wouldn't it be way faster to learn power rule? Like, that
All my people that have taken calculus before, you know there's shortcuts to this. Right? If you haven't taken calculus, you're actually in a better place because you're not going to make the mistake of doing too much too early. So before we get to chapter 3, I don't want to see any freaking shortcut shit for derivatives. Yes? Why am I not teaching you the shortcut? Because shortcuts are built on ideas. We have to go over the idea first, then we're going to see why the shortcut works, and then we're going to have a shortcut. I can't see why the shortcut works until I understand this process. But that's a good question, right? It would be easier to do it, but you wouldn't get the understanding that you need. And if you disagree, it's too bad. I think that was it. Yes. Let me give you this, and then we'll call it a day. This is a little something we'll go over on Friday as part of our review. Don't worry about the back. Just save this for later. The back's got 2/8 on it, right?
Oh, does that mean that 2/8 homework isn't due till next test?
That's right.
Okay.
Just make sure everybody understands. 2/8 homework is not due until test 2. Scramble for that before test 1. Once you get this thing, you can head out. If you have any questions, let me know.
And you just do it anytime, or
What's that? No, we're going to go over it Friday. You don't have to look at this right now if you don't want to. All right, guys. Let me know if you have any questions. Otherwise, you can escape.
Wait, can we watch Pulp Fiction for extra credit?
That's a great
Can we watch Pulp Fiction for extra credit?